So today we are going to officially start talking about object-oriented programming. If you have read the fine print, you might have noticed that the name of this class is in fact C++ OOP. Is C++ OOP. So we have at long last arrived at what object-oriented programming is. So I know you're all just dying to find out, like, what is that? So a lot of what we have done really up to this point is stuff that you could have done in the language C. There's a few exceptions to that. It didn't have stuff like vectors, but I mean, the theory of at least a lot of what we've done, everything we've done to now with functions, with separate compilation and headers and a lot of that stuff, that's all stuff that the language C was able to do like back in the day. That's called procedural programming. It's still the best way from the ground up to understand how programming works. And you can still do it with a lot of languages. A lot of languages still work that way. But C++, the reason why it has really been a boss ever since it was developed by Bell Labs in the 70s. And, you know, the source code, for instance, for Google Maps is written in C++. The YouTube and Google algorithms are also written in C++. A lot of the stuff that undergirds a lot of the big companies you've probably heard of, from Amazon to Netflix to Facebook, all of those, like C++ is kind of a popular go-to language because of what I'm about to describe to you. It is an object-oriented programming language. That's OOP for short. Java is another popular language that perhaps you have heard of. It's pure OOP. It actually, you cannot program in Java using procedural programming. So it's kind of a step up to kind of wrap your head around how Java works. And Java is actually one of the many successors to C++. C++, a big thing that it has going for it and why it's really popular is that it is fully object-oriented, and you can also use it procedurally, as we have done up to now. C++ accommodates both styles and is complete for both of them. Python is another programming language. It's kind of a new kid on the block that's really grown in popularity in the past like 10 or 15 years. And some of what Python does is OOP. A lot of some of it's also procedural. The thing about Python, though, is it's very streamlined to do specific kinds of things. And so Python is very object-oriented in the way it does things, but it's made to do specific kinds of things, mainly related to like statistical analysis and making graphs. C++ is a lot more versatile in the kinds of things it can do. You know, C++ code is actually also, it's been used on like pieces of NASA hardware. So for instance, the rovers that they're driving around, those also tend to have C++ style code undergirding how those machines operate. So that's sort of what's OOP, I guess, is, and like why it's awesome and why it's worth knowing about. But what actually is it? Object-oriented programming is about the creation of classes. And what a class does is it gives you a way to organize the stuff in your program. An object is a particular instance of a class. So when C++ was first developed, the original name was C with classes. and it took the procedural language of C and then basically added more stuff to it. So first, we're going to talk about encapsulation here. And maybe we're not quite so ambitious. We're not going to do like a NASA Mars rover, for instance. Maybe we're going to design the computer programming for a vending machine. So, we would first want to kind of think about and sort of encapsulate, sort of capture all the stuff that a vending machine needs to do and it needs to keep track of. So, for instance, a vending machine should keep track of like how much money people have put into it. I have seen vending machines now where they even let you like swipe a debit card and stuff like that, which is pretty nice. But if you're talking about something that's just like taking in coins or dollar bills, it's going to need to keep track of the money that it's getting. It should also keep track of like how much stuff is in the vending machine. It might we might want to automate it so it'll like send an email to like somebody at the home office and be like, hey bro, I'm out of Pepsi's, I need you to help me out. I mean, whatever, something like that. So in object-oriented programming, we have to identify objects. So any single vending machine is going to be an object. And then what we would do is we could create like a broad class that describes all vending machines. So the class vending machine is a description of all types of machines of this kind. They could dispense candy bars, they could dispense sodas, they could dispense chips, they could have some kind of combination thereof. There's vending machines that do like coffee and hot cocoa too, but that's a thing. And so like all of these instances of vending machine, these are specific objects. These are instances of the class. These are individual members of the larger group. You could have like the soda machine in the lobby, the snack machine in the lobby. There's an ice cream machine in the break room. There's a soda machine there. There's a snack machine in the break room. And then there's like a fruit juice machine over in like the office or something. Just there's bunches of specific items that are members of this class. So if we have a vending machine class, we can create code that will apply to all vending machines. So it really lets us streamline and sort of encapsulate everything that has to do with a vending machine, and we can put it all in one place. And the nice thing about doing that is we don't have to keep writing code over and over again, or even having to like cut and paste code is a bit of a drag. But we can encapsulate an object and just store it in one place and tell our compiler and be like, hey bro, anytime you see vending machine, it's got these things that are a part of it. And so we can use the same sets of instructions over and over again. We can use the stuff we've been talking about for like, having functions and having sort of separate ideas in a hierarchy. We can have all that stuff encapsulated in an object of like one-stop shopping for all of that code that apply to a particular kind of object. What that does for it is we're not limited by the type of machine. In the grand scheme of things, a snack machine, a soda machine, an ice cream machine, a fruit juice machine, at their core, they're not like radically different. I mean, you might need more of a, I guess, high-powered cooling element for an ice cream machine, but that's a hardware issue, not a software problem. So we're not limited by the type of machine, and it doesn't even matter like where the machine is. And you could like pick up and move the machine if you really wanted to. It's not going to impact the programming. So a very basic example. This code isn't going to really do too much here because it doesn't have a whole lot in it. But like, if we look at this, so we're going to do our usual headers. We're going to include the input-output stream. We're going to include the standard namespace. And so what you would do if you're going to make a class is you would use the keyword class and be like, hey, bro, make a class. And then be like, hey, I'm going to call this class vending underscore machine. And then you put the like braces. The big thing, the way a class is different than say like a function, because this probably looks an awful lot like how we define functions. The big difference, and this is a little annoying thing that's easy to forget, but when you're done defining a class, you do have to put a semicolon at the after the final brace of your class definition. This is like the one time that's ever a thing. Most of the time you like never do that. But when you define a class, you're gonna have to put this semicolon right here. And then what you can do is you can, when you make a class, it's basically like a type of variable. Vectors are in fact a class. Strings are a class. They have functions that do specific things. Like, you know, with vectors, we had ways to like find the average of all the numbers in the vector, for instance. There was this pushback function in vector. Vectors are actually a class that are made up of basically a list of a bunch of ints or floats or something like that. So vectors are a class. And so just like we would do here, you know, a string is a kind of class. We're going to use it just like a variable, like int or float or bool or whatever. So we're going to declare an object vending machine. This is just like if we put in int, and then we would give it a name, and we could call it like the lobby soda machine. Now this program's not going to do much when I run it, but because there's like nothing here. But it's like, hey, all right, you made something. Good for you, bro. So there you go. That's kind of how that's usually how I react when my 3-year-old shows me something he came up with blocks. It's like, you did something, bro. Good for you. Anyway, so we defined a class vending machine. It's just like a new variable type. We've seen many int, char, float. After we define it, we can then use it in a program. So, you know, we define the class and then we're like, hey, make something of that class. And then, you know, it didn't do anything, but at least it didn't give an error message, which is a good sign that yes, this class does have the bare bones of something that functions, and then we can actually put stuff into it. So fun fact, even though it looks like a single variable, it actually is going to contain more variables inside it. So what we're going to put in our vending machine, we're going to keep track of the money for the credit towards the purchase. So like if somebody puts in a quarter, we want to keep a tally somewhere and say, okay, that's 0.25. And then, you know, store that information somewhere. So that if they put in a nickel, now it'll be up to 0.30, something like that. We would then have another thing where we would keep track of the total collected. So, you know, if it's sitting there for a month, maybe it'll take in, I don't know how much they take, maybe like $50, like $48.60. Who knows, whatever. So, you know, it would have like a grand total of how much money it has in it. And then it probably has a limit to like its capacity. So then when somebody comes to like put more sodas in it, they might also want to like take the coins out of it. Something else we'd want to store would be like the prices of the items that the machine dispenses. And we probably want to keep a running count of how many items are in the inventory. And then when the inventory gets down to 0, or maybe when it hits like, you know, under 10, maybe some sort of threshold where it'll let us know, it's like, hey, bro, I need you to restock me and give me more sodas. Let's see. So all of those things would have a variable that stores that information. And then there's also operations or actions that the vending machine is going to need to do. It's going to need to take the money in. It's going to need to vend items. It's going to need to give back change. And it's going to need to report its inventory. So those would all be functions that that are specific to this class of things we would do with these objects. And again, we've kind of seen this phenomenon before. We're like, with a vector, there were actions that you would do with the vector. You would push it back where you'd make it bigger. You could do things like do a count of how many things were in the vector. You could, if it was numbers, you could find the average or the mean of what was in the vector. There were lots and lots of functions that you could apply to vectors. So those actions or operations, we would do those using functions. All of the variables and functions are stored in a single package called encapsulation. And so I've mentioned them already. There's three classes that we've seen actually before, which are vector, string, and then we also looked at file stream a little bit. You know, a vector is a special class that's made up of arrays. A string is made up of characters. The class file stream is variables and functions related to files. A string S from the string class has char variables to store them. And it has like a length function, which just counts the number of chars. So big picture, when you make a class, it's going to contain multiple, usually, I mean, you could have just one or none if you really wanted to, but usually a class is going to have variables to keep information and then functions to do stuff with that information. That is a class. So let's look at a member function of a class. Let's have a function. Let's see, we're going over here. So here we're including string. We've got a string S that is hello. And there's a member function s.length. And by the way, if you've used Python, this should look familiar because Python uses this syntax all the time when you are applying functions from classes. So like s.length, that's a common way that Python is coded because it's designed in a fashion similar to people who already know C++. But s.length, length is a member function of the class string. And then when you run this, it's basically a function that tells you how many characters there are, which happen to be 5, because hello is a 5-letter word. So that's an example with that. So that's kind of the big idea of encapsulation. You make a new kind of variable called a class, and it is going to be specific instances of it are called objects. And then these classes, each individual object will have a bunch of variables that store information and a bunch of functions that will do stuff with that information. So that's kind of a broad overview.